My name is Raj Jalan. I'm the CTO for A10 Networks. I've been in the industry for 30 plus years, and so at NET, Centillion Bay Networks, and Foundry prior to joining A10. And this is my 10th year at A10. I joined as a part-time consultant, and increasingly over time, things get more and more interesting. And today, the time at which we are in the industry, it's incredibly exciting. Everything is changing, and the opportunity to build new exciting products, particularly in the application networking space, is quite unlike anything else before. So with that, I'd like to take you on a small journey on ACOS, how we have developed a platform that enables us to build rich application networking services. I always look at rich when, rich is around. So, lately there has been a lot of talk about SDN. SDN, people are still trying to figure out what that means. To me, SDN is doing networking right, simply defined networking. I don't want to, obviously I need to create the infrastructure to begin with, but then after that, I don't need to allocate IP addresses, VLANs, network interfaces. That's just a very slow way of doing things in today's day and world age. People do expect a lot more from the network. So what does simply defined networking mean? Simply defined networking means that I don't want to really deal with a lot of details. I as a user, I as an operator have policies. I need to run my business. So I will define which kind of users based on their context and what kind of applications they are trying to access, whether they are on a mobile device, home device, corporate, VPN or whatever. They need to provide all the access to resources and content wherever they may be in an on-demand fashion. That is really the requirement at a very high level. So how do we able to do that? Lately, there has been a lot of talk in the industry. We have internally been talking about this as well. And so from a user's perspective, give me an ability to define what I want to do. Don't tell me, I need to configure all these, details, myriad details. That will all happen through automation. So that is really where we are going. I want to be able to specify what I want to do, and then I want to see that that's what's happening and making sure that things worked out as I had specified, an assurance, a compliance, an audit. Now, the beauty about this approach is obviously the only way to do this is through software automation, correct? So it translates, this very high level definition of simply defined networking translates to a requirement of agility, of automation, of security, policy, compliance, audit. All of these things need to happen at the same time while reducing CapEx and OpEx. That is the beautiful opportunity. It is not one or the other anymore. If you do it right, you can achieve all the benefit, get more secure, more compliant, more agile, more dynamic, and that's beautiful. All of the things that people have been trying to do in various ways can be done all together. This is the application networking world, the world of IT that we are building towards. There are a lot of big initiatives from a lot of big vendors. We are a very important part of the ecosystem. As you can tell, a lot of frameworks exist around SDN, but application networking services are very key. Traditionally, the world would be a great place if everybody had access to everything, right? That would be beautiful. But reality is, unfortunately, that's not the world we live in. We need to erect a lot of, metal detectors and security gates and pat downs and remove your shoes and all kinds of inspection that is prevalent everywhere. We didn't invent that. We wish it goes away. But in the meantime, we have to make that all work. So this is really an example where this is an example which shows a representation of users in a context-driven manner accessing applications, and ADCs and application networking services play a very critical role, whether it's enterprise or service provider, because these are the devices that take the policy and enforce the policy, application availability, optimization policy, security policy, compliance policy, and also report to ensure that that's exactly what was met. So application networking devices have a huge role in this simply defined networking world. This is what makes clouds possible. This, whether it's physical, virtual, private cloud, public cloud, hybrid cloud, what have you. It is through this means of simplification is it is possible to achieve the goal that everybody is talking about. So that was the goal. So how do we go about doing it? See, to achieve these lofty goals, you have to really rethink your whole solution. So first and foremost, that translates to requirements for vendors like us in the application networking space is to provide multi-tenant, multiple services. Why is that important? Why do we need to do multiple things? As you guys all know, that ADCs have evolved from very simple server load balancers. There used to be SSL offload to be styled. Compression used to be another device. Consolidation is important because it is difficult for users to manage too many devices. You have to, each device that you have to manage, there is 10 things that you have to do before you can start using the application. So consolidating all of those things reduces cost, simplifies, and all of that. So that is why consolidation is a very important thing. One of the things that's happening in the industry today is people are talking a lot about service chaining. That's a great thing. And obviously there will be customers who say, hey, I use only best of breed components. So here I have 20 different vendors' products. Now that is a beautiful thing. But when it all works, I can sleep at night and I have the best solution. But what happens is that's actually far from reality. There will be a lot of troubleshooting, monitoring, debugging. I mean, just because you have the simply defined networking world doesn't mean that, there is nothing to do. To make that thing work, there is a whole backroom operation where there are a lot of smart people trying to make that happen through automation templates and then having the ability to debug and troubleshoot things. So, I liken that to, my car has a dashboard. But is that enough? No, actually, when the car doesn't work, I have to take it to a garage. There they use sophisticated tools and other, manufacturer tools and other industry tools to troubleshoot and identify what's the problem with my car. Similarly, for application networking vendors, there will be a need to build management solutions that are geared and tailored to troubleshoot and report and provide rich services around specific products. So that's really what's the design principles of the ACOS platform. Obviously, high availability, scalability, flexibility, programmability, extensibility, these are very, very important things. You need to be able to combine things together, extend things together dynamically, and program this stuff. SDN ready, when I say SDN ready, meaning more the network layer of things, whether you have overlay, underlay, OpenFlow, what have you, VPN, MPLS, whatever. It just needs to play nice with that. Everything needs to work in a cloud environment. Whatever be the management systems being used by enterprise or service provider, OSS, BSS layers, OpenStack, Cisco ACI, and many NSX and other things that will come. These are not the only ones. They are the ones that are leading today. Many others will come. So all of these things are the design principles that drive ACOS, because this is the opportunity. We started late. We started in 2004-05 with multi-core technology. We had the opportunity to rethink the whole problem and enable solutions that actually move the ball significantly forward. So this is basically now taking you into sort of the ACOS architecture. Really, we divide it into 3 layers. One is the platform layer that provides a lot of rich infrastructure services, because every time we have found, and through experience, when you ask an engineer to solve a problem and he's building infrastructure, it's not the best because he's not the infrastructure professional, and each developer is doing their own infrastructure. They're all inconsistent, different, difficult to use, buggy, and all that. So pushing, much like an operating system like Linux is very popular, Windows somewhat, whatnot. So the more richer services that are in the operating system, all my applications can leverage that. So we have adopted that design principle, and we're pushing a lot of the capabilities into our ACOS platform so that all of the services that we build can leverage the same beautiful services. So because really, anybody who's used any networking product knows that a lot of stuff is in the platform, and then there is the application. So consolidating all the common components is a good thing. You can get best of breed functionality that way. Then the application services, it becomes easy to say, hey, I need to do this business logic. I have a rich supporting ecosystem. Boom, I have this service A, B, C, D. my life is easy. So that's really application and security services we'll talk about in a moment. And then finally, the management piece. While there is the industry standard single pane of glasses that will be built by big vendors, there will be a need for every vendor to provide very comprehensive, very detailed management platforms that take care of that vendor's products and solutions. So that is very important. And that is what helps to integrate into the overall big management system as well. In the past, networking was bottoms up. People used to build products. Then they said, oh, I need an SNMP MIB, or I need this CLI or this API. And it was kind of building from the ground up. A good city, a good infrastructure cannot be built from a bottom up way. It is top down. So that's really the design principles. So what have we done? Core elements. 2004, 2005, we designed what is called as the scalable symmetrical multiprocessing system with shared memory architecture. We'll talk about it in a moment. Because of the advent of multi-core technologies, nobody was taking advantage of it. We saw a beautiful opportunity, and we'll talk about it in a second. And most recently, in our 4.0 release, we're adding what is the most significant advancement in our product line, which is the policy engine, which is enabling full CLI, full manageability through RESTful JSON API for every CLI parameter that there is in the system. So we are one of the first vendors that will have a very comprehensive, very shortly, fully RESTful API to manage everything. Not just 3 calls for OpenStack as in LBAS, but every of the 1,000 commands that we have and higher for each of the services that we actually build on top of it. So we have built a engine where you, through schema, you can define your CLI, and lo and behold, the API is rendered immediately. So that's something Mike will talk a little bit more about. And a powerful event management system. So that's really the new thing. At the infrastructure component, there are a lot of infrastructure components that any networking product needs to have. Large scale buffer and session management, because really we are a layer 2 to 7 product, mostly stateful. We process millions and tens of millions and hundreds of millions of session state. Lots of buffers. We're not talking about 3 megabyte buffer as in Trident. We're talking about hundreds of gigs of buffer memory, because we have to buffer a lot of data. So first class buffer and session management, virtualization, built-in virtualization into the ACOS platform, because as you're familiar with Cisco A-style context, we do have multi-tenancy where you can have multiple logical tenants within our device for each of the services that we have. And I did not think that anybody would want to enable multi-tenancy in a VM, but yes, we have customers who have asked for that as well. And ACOS, because the way it is built, it's a software-defined platform. Same software can run on a physical machine, virtual machine, AWS, Azure, and many other cloud environments. Same exact thing, software-defined platform, same rich services.
Do you have a controller of controllers within your own platform? So if you have multiple ADCs deployed, are you going through, is this showing that kind of platform, or is it APIs per box?
So we are building up. We have been shipping for many years what is called as virtual chassis system, which is kind of an aggregation. It's like a stacking system where you can take multiple devices of the same type and build it out. So that's one thing. Now, the thing that we are going forward and doing is we have some interesting architectures. Hopefully, in the next network field day, we will be able to do a deep dive on that, which is very powerful architectures, which are slightly different from what the industry is doing. We believe that really data plane controllers is the really only scalable way of doing large scale systems. So we'll see that in the future. And today we are working with working on integrating with Cisco ACI, NSX, and those controllers as well.
Right. So let's take if we took ACI as an example.
Yeah.
The AP controller would communicate with each A10 ADC, or is it communicating with
okay, in a moment, in the third slide from now, we'll talk exactly about that. So we talked about virtualization, visibility, and telemetry, very important, because remember, it's not about provisioning alone. That is only 1/3 of the battle. The bigger battle is it working correctly? Do I get all the information from it? Can I prove that it worked? And can I do accounting, charging, billing, all of these things? Scripting is one very great decision that we made early on to make our platform compatible with the industry leader F5 at Tickle scripting language. That has been a huge success, and so that is one of the very, very powerful capabilities that is present in our platform that can be leveraged across all our solutions and services. And finally, troubleshooting. I know you guys place a lot of emphasis on troubleshooting because ultimately, you know what, no product is perfect, but how can I, quickly resolve the issues? And that is extremely important. We have taken a lot of, paying a lot of attention. Each of these areas, we have substantial feature set already, and the feature set that we have upcoming in the future releases is even more exciting on each of these topics. A lot of good infrastructure already built, but a lot more great stuff coming up. Networking, extremely important. Traditional IPv4, V6, layer 2, 3 standard networking, VPN, IPsec, SSL, VPN type of capability to do connection between, different disparate domains, SDN, overlay, underlay, OpenFlow, all of these things, rich networking capabilities are basically, application delivery devices, application gateways. They're like Swiss Army knives. They're gateways. They connect two disparate domains which would not otherwise talk. So any-to-any connectivity. And unfortunately, there's more protocols being invented every day even now. GNV is one more example, like fine, VXLAN and NVGR even not sufficient one.
What encaps do you support today? Do you support VXLAN?
Today we support VXLAN, NVGRE, IP and IP, DS Lite, which is more in the IPv6 migration, and many others.
So with regards to scripting, you mentioned TCL. What about Python support? Have you got any plans for that?
Well, integrating Python support, we do have Python support for our API, but we're not running Python on the platform yet.
Okay.
Yeah, I'm going to cover that in the next section.
But that's on the API side of
when
things.
we talk about DevOps enablement.
Yeah.
And then we'll get into that, what we have today and what we're actually reaching towards in the future to solve some of these problems that you're probably on top of your head thinking about.
We do have plans for the future in how we extend our system to enable a lot more richer capabilities. Unfortunately, not a good topic for today. We're very excited about that, but we'll have to be patient on that. And so then orchestration, what do we mean by orchestration? This is really network type of orchestration where we mean high availability, scale in, scale out, all of that. That is very important to build into the platform because you don't want each application to do things in its own way because that's not going to scale. So by doing this and then enabling, the platform enables built-in service chaining, handling multiple services, and most importantly, the programmability of it, which is the RESTful APIs. So this is really an investment that we realized very early on important to make because all of the great companies really have good platforms upon which they can build their applications and at some point in time also open up the platform in a way that ecosystem, developers, system integrators, value-added resellers can add applications and services on top of that. So that's kind of the direction that we are going. So that's really the ACOS platform. This is a platform that enables all the rich services that we'll talk about shortly. So now we'll talk about the scalable SMP architecture, which is at the bottommost layer of our platform, which is one of the significant differentiators for A10. So you have a device with 1 gig, 10 gig, 40 gig, 100 gig interfaces. We ship all of those, by the way. So we are probably the only ADC vendor that has 100 gig interfaces shipping today. And so traffic comes in. So we call it as a flexible traffic accelerator, which can be hardware, or it can be DPDK type of driver or other IO drivers depending on the platform that take the traffic and design fundamentally for multi-cores to distribute the traffic using proprietary hashing algorithms so that most of the traffic gets fairly evenly distributed across all the cores. And this is where goes into shared memory, and the shared memory is a very key architectural principle because it is like collaborating in a room. Having this meeting over the internet would not be so much fun, right? Yes, there are people who are on the internet, but for the core group here, if each one of you in a different place, it would not be the same thing, right? The communication is not quite that effective. So having shared memory is like being able to see the same whiteboard at the same time, not through telecom means, but really sharing. That enables tremendous flexibility and agility in problem solving. We have been able to use this number of times with our customers when they said, oh, here is this problem. Within a week or two, we are able to solve the problem because of the agility of the platform. We talked about that. We talked about rich networking capability and the policy engine that makes the programming of all the capabilities of the platform very easy. So this is the platform that enables us to build the rich services that we'll talk about. This is just a slide that shows how the shared memory architecture that we have has enabled us over the years, 6-7 years that we have been shipping. Early on, 2-core Woodcrest processor. We were about 120K CPS, and today our high end with dual 12 cores able to do 7 million connections per second. This is an example of scale and throughput that has pretty much scaled linearly. High scaling and performance is not the only advantage. There is tremendous advantage in how we can solve problems which are harder to solve. Remember, this is not the first product that we are building. We have built many products before. We've seen all the pitfalls of other architectures before, and so we designed this system to really solve many of those problems. Intel has helped us significantly. We kind of ridden the Intel's curve, and tick tock, performance keeps going up. We just focus on our business. So we are able to leverage industry best of breed components like Intel, Broadcom, and whatever other comes in. So this is an example of application services, application delivery services, security services, policy and optimization. This is what most of the application developers around here do. And we have all of these capabilities that are shipping today, and many more exciting things being built as we speak. So the good news is that the first application delivery controller took us about 3-4 years to build and ship. The ADC CGN took us about 18 to 24 months to build and ship. DDoS took us 12 months to 15 months. So as you can see, that building new capabilities is actually a reducing time scale for us because of developers are able to leverage the tremendous platform. The platform is physical, it's virtual. The same thing runs in AWS. The application developer has to do nothing. They just write their code and it works everywhere.
Can you run all three concurrently, or do you pick which service you want to run on that platform?
Absolutely. As I said, multi-tenant, multi-services. Today we have skewed it in a way that they are running separately. In 4.0, which is the upcoming release, we are allowing multiple concurrent services. And so this is very important. Remember, service chaining. Distributed service chaining has its merits, but a lot of customers will try to consolidate that. Say, hey, I want these service A, B, C, D, but can I do it on the same platform? That would be nice, right? Kind of reduce the number of components, reduce latency, more optimization, one look and feel, one UI, one throat to choke, hopefully not.
For smaller customers, that helps too, right?
Totally. No, even larger customers, because you know what? It's not about, yes, I can do service chaining, but do I want 20 different devices? Not really. I may want 20 services, but do I want 20 devices?
Sure.
So consolidation is still a trend. People are trying to do distribution, but they're trying to do also consolidation at the same time. Ideally, you want to reduce the number of networking devices that are in the data path, right? Because each device adds its own latency and fun challenges.
Sometimes I feel it's maybe not specifically about trying to consolidate devices. Sometimes the challenge we have is consolidating points of control. Mm-hmm. So like I would like to have something that I can distribute out easily so I can get the scale and load I want, but that's been a challenge because then now I've got 100 devices to manage instead of 10 or whatever, So it's the points of control is probably of more interest.
So absolutely right. So we are building in a way that we have the platform, rich services, then I'm building so many services on top of it. You can, through policy, placement policy, instantiate many of those services on the same consolidated device, or you can distribute them and they'll all work seamlessly together. And that's really the capabilities that we are building. Absolutely right. So this is the most important component. This is the most neglected component in the past, network management. People say, oh, SNMP developer, I don't really want to be one. But nowadays, network management is very interesting. That's really where most of the fun is. There needs to be a lot more developers doing great network management, because ultimately the network is just a thin client. The networking device is just a thin client trying to enact the policies set by the policy setters. The network device is not the boss. The boss is the network management station. So just like ACOS Platform, we're building a new network management platform with core services like device management, authentication, monitoring, troubleshooting, reporting, logging, because we have a number of services. Now, again, the view today is you manage devices. Centralized management is a single pane of glass for managing multiple devices. But if you take the NSX view of things, which is slightly different from the ACI view of things, ACI is trying to manage each device separately. NSX saying, okay, you know what, I want to manage a service. I don't want to manage devices. OpenStack saying, I want to manage a service, not a device. Let that be the problem of a vendor-specific management solution, where that service gets placed.
I missed the thing about managing devices separately. What was that about?
Well, so for example, Cisco ACI today, and today many other centralized management, they're aware of each device, right? As a high-level manager, if I'm the CEO or highly positioned, if I try to manage each individual engineer or developer, it's not a very scalable solution. So I manage, my reports, who are then in turn managing underneath, right? Okay. So a top-level manager trying to manage an end device directly is not a very scalable solution, because it becomes too complicated, too detailed. So there needs to be abstraction. So when I say I need a VIP, right, it is really a load balance service. I don't care where it's placed, whether it's placed on a physical device, on a virtual device, or it's placed in the cloud. That's a policy that is driven by other detailed parameters which I'm not setting. So let me hand that task to a management solution that is specialized in solving that problem. So take high-level policy, translate it to kind of mid-level policy or service definition, which then gets translated, compiled, synthesized, whatever you want to call it, to device configurations that are dynamically built out, allocate IP address, program FQDNs, and all of the stuff which really automates and makes things agile into the infrastructure right now, pull things, connect things, make it work, then manage, get the telemetry feedback and say, hey, you know what, exactly as I desired, oh no, it's not working, let me troubleshoot. So this is really the capability of these types of vendor management platforms that will be absolutely necessary. OpenStack will not be able to give you that, because OpenStack is trying to solve the higher level management problem, not the lower level management problem. There is not going to be just one management platform. So this is sort of the mechanics dashboard, if you will.
So,
then there is
to clarify, if it's OpenStack, LBAS, or ACI, then those APIs are communicating to this A10 management solution?
Absolutely. So you see this provide northbound APIs, which then can be leveraged by OpenStack, NSX, and service provider OSS, BSS, or they can also talk directly to the devices if they so choose, because these devices provide RESTful APIs as well. So there's RESTful northbound APIs provided by the device, there's RESTful northbound APIs, but this is value-added services management, troubleshooting, reporting, logging, all of that stuff.
In that statement, does that mean value-added services mean additional cost? Otherwise, why not deploy that?
Well, this is not really a money-making business in the sense this is to enable, this is where the volume is. Hopefully somebody will pay for this. And then this is, sold at a reasonable price to make the solution work.
I think there's also another component with this, right? Everything we do in technology is to solve business problems. So if the business says, I need this sorts of data aggregated across or consumed or collected from these endpoints, and we have a little knob that actually allows, you to start initiating a workflow, send an out of office message, whatever you need to do. I think when you start getting into these endpoints that are enforcing policy in a data path, that sometimes those aren't the right places to start making some of these higher level decisions. Actually, it's up compute and stuff. So one of the things that if you start looking as big data and analytics and information sharing becomes more and more important, as collaboration becomes more important, you need a collector. And our platform is actually going to be designed in such a way that actually is optimized for our environment. One of the problems inherently with the cloud architectures is that you have to kind of water everything down in order to get a very common functionality. It doesn't work when you're actually trying to solve real world business problems and you need something very specific. So that's where we're ultimately going to do things for our very specific environment in a way that no one else can.
Yeah, it makes sense. Again, if I'm looking at it from a cloud perspective, ACI NSX, just make it a requirement. You need this. Like, why would you want to have that vendor develop some complex package to communicate with like 10 A10 boxes? Just say, hey, you need this A10 management solution to integrate because we're going to create a VIP. Don't worry where we create it, but we're going to create you the right VIP in the right ADC. Right.
And the upper level management can specify the policies that I want the cost to be within this parameter. Specify policy and translate policy to the lower level operational parameters, because that's really how management can work best, right? And that's the opportunity. In human world, it may not work very well, but in the automated world, it is possible to make it work because machines don't have emotions. That's good news. So with that, really, this is kind of the final piece of the overall architecture. And so what are we? So this is like the summary slide. So highly manageable, because before configure from bottoms up, now we are saying everything is top down. That's where the world is headed. Management through high level management, instantiate whatever products and services and solutions that you want on our platform, other platforms that are present in the system, and then on different form factors. We said physical, virtual, small, medium, large, Azure, AWS, whatever platforms are available to instantiate our products on, to deliver enterprise service provider, hosted, whatever IT delivery and IT data center service provider networking solutions that may be required.
Do you integrate with any hypervisor APIs so that way if you were in the management platform, you can spin up a new virtual appliance, or would you need, let's say, a vCenter or KVM admin to go deploy that first and then import it to the management platform?
So the way that really will work best is that we are building a lot of advanced telemetry utilization information into our product, and that information is being observed by the network management platform, whatever that may be. It may be heat, it may be ceilometer, it may be our own orchestration solutions that's observing that, okay, I need to provide an SLA, such and such LSA for this service. Now, okay, this is getting overloaded. Let me spin up another service. I don't think really vCenter or those types of infrastructure as a service is the one that really needs to be worrying about that. It's really the service management layer that needs to worry about that.
So to be a little bit more poignant with your question, right? If we look at OpenStack, right, there's a lot of problems within the Neutron community, specifically on services VM, right? So there is no real support for spinning up a system and actually managing it. So if someone's dealing with basically trying to stay with the upstream, release, then it makes it very hard to solve some of these problems. Now, when we start talking about like NetX integration or NSX, right, these are things where we can actually, they have the APIs, we can use VCAC, we can actually just make callbacks in the vCenter directly. Yeah. And so it really...
To be fair, there's like 90% non-cloud environments out there. It's just virtualization.
Yeah.
So it's, again, no OpenStack, no VCAC.
Yeah.
So traditional vSphere, vCenter,
or
KVM.
But it's still in the same SLAs.
Right. Yeah, and that's the point. It's just seeing if there's like lifecycle management natively built in, and a lot of platforms like there aren't. So it's, but it just streamlines the deployments if that was built in.
No. So actually, with our A Galaxy framework, one of the things that we're really focused on is exactly that: lifecycle of policy, lifecycle management of policies, of systems, of applications. And when we start actually looking at that, you're absolutely right. I mean, you hit the nail on the head. We have to go for the big guys, right, and say that we integrate with these APIs and do these things. But at the end of the day, my experience in the past, as an operator, there was lack of automation, and there was still a lot of manual provisioning that had to be done. And these are things that can be easily taken care of with, again, just integration. vCenter, ESX, KVM, these all have APIs, or even we can even dump packages on there to integrate with these environments, so we can even do it ourselves.
You mentioned you had some kind of an orchestration product that kind of does that, right?
Yeah, we are building.
Very briefly, you mentioned.
We are building, yes.
Yeah. Okay, so you're building that currently.
Yes.
Yeah, because that's kind of like the low-hanging fruit to kind of match both use cases. You can say, okay, I need to have an answer for those that run OpenStack, so we'll build a plugin that integrates with that piece of software, and then if you don't run OpenStack, that software is still valuable. That way you don't have to integrate directly.
Raj, we need to get together.
Yeah, so this is the last slide, and so I just wanted to make one final statement. So Lee, our CEO, and we've had a vision. ACOS everywhere, that's what we used to call it. So it's really taking our platform and enabling more and more services and instances of that. Slowly but surely we are realizing that dream, and it's it's so exciting right now that though this is my longest job, 10th year, every day feels like first day at work.